So, hello everyone. Lucas is just here setting up. We are going to be live on the recording very soon, and presenting in about 5 to 10 minutes. So just fast forward and we'll be there. Cool, thank you.
Apple AirPlay, you reckon?
Yes. Yeah, that's how we did it last time, and it worked really well. At least how I got it to work.
No idea. I didn't organise this.
Live Lounge is where we are. And it appears on the screen. Projector, HDMI, video network. What's it going to be? It's not going to be digital link. Ah, here we go. 6636, I think, maybe. Yeah, see if that works. I'm not sure it will, but... Something came up for a second.
So that's on the Apple TV, is it?
Yeah. Now I'm playing around on this is the actual projector itself.
Yeah, I get that, but shouldn't it be like... Shouldn't we plug into... But the projector should be plugged into like an Apple TV, right? It should be on like HDMI.
I don't know, I thought this thing natively did it.
Oh, I think we'd be going to this guy here, the Apple TV, which is on HDMI.
Okay, alright.
It's just like another device.
Yeah, that's got a light, so that should be on. So there's no signal out of that one. And that one is going into HDMI. Here we go. So I reckon I need to change this to HDMI 3.
It's not one of these things that go through the amp and then you have to do that.
Yeah, I think I need to change this. And I'm trying to work out if it's... So I think we've got Apple TVs here. And so this is not the current sense of that, which is there. So I need to change that one.
That's what it's saying, right?
Yeah. Yeah, or you could plug this HDMI cable. Do you have the right connector? Yeah. I think it's 3. Is Apple TV, and 2 is this cable here. What did you press? Oh, that one. Yeah, so I think that should be that cable. Yeah. But the DP is stronger.
Someone spent a lot of time setting all that up.
Yeah, we did. We went through all of this cable last week as well. I'll just get Chris Mackay knows all about this setup. So, we're coming in on this cable here, essentially like 2.
I think it's actually 2. Okay, let's try some different way. It's Floaker, right? Great.
Full airplay.
Yeah, brilliant.
Solved.
So,
I don't know what they've done to the HDMI recently. It's just, maybe it's just like cables dead.
yeah. Yeah, so I will touch this no more.
Do you have the Wi-Fi access?
Cool.
Easy.
Okay. So, hello everyone. We are live, or almost live, which is fantastic. Hello everyone on the live stream. We're just about to get going. Hello everyone here. So today we've got Lucas, who is busily tapping away on his keyboard, and it's actually appearing on screen, which is even better. And he's going to tell us all about Vyper, which is going to be very, very good. So, I hope so. I hope that we're all going to walk away as experts.
Say again? Oh yeah, I've just reused slides from an old meetup. So.
We're all good. All right, Lucas, please take it away.
Right, is that camera two?
Yeah, and I'll zoom in.
Alright, so today we're going to do some smart contracts in Vyper. So a bit of background information on smart contracts, just like 2 seconds, and Vyper. This is taken from the Vyper GitHub. So it is an experimental contract-orientated Pythonic programming languages that targets the EVM. So I guess the takeaways there is it's experimental. So maybe think about that when you're using it for things. And I like this term here, contract-orientated. I'll talk to that in a second. And Pythonic programming language, so it takes its origins from Python. So any Python developers here? 2. Cool. Well, I kind of like Python, so this is why I got into, started doing a bit of Vyper. So the EVM overview, so those who have come to these before, we know we have these high-level languages called Solidity. We used to have Serpent, but that died. for whatever reason, and now we've got Vyper. And the idea here is we can, as developers, express ourselves in these program paradigms. Solidity is very object-orientated, and Vyper is kind of contract-orientated. And then we go to a compiler, which parses the high-level language into a bunch of opcodes. With Solidity, the compiler is Sol-C, which is actually written in C++, where Vyper is actually, the compiler is actually written in Python. And I like this approach because if you're a JavaScript developer and you're familiar with JavaScript and Solidity and you get stuck, it's sometimes hard to then work out what Sol-C is doing because it's written in another language. So when the smart contract language is close to the compiler, I think it makes sense and it's nice. And we all know opcodes, and we've talked about them enough, and we can see the yellow paper. So again, the principles of Vyper. These are just taken verbatim off the GitHub README. So security. So it should be possible and natural to build smart contracts in Vyper. And they do this by making the language simple. The language should strive to be simple. So I'll talk to what some of how they make it simpler in a second. The contracts should be auditable. So we argue that Vyper is more human readable. They use operators as not written as NOT, not exclamation equals. So that's why I guess they claim about audible and readable, which should have better security. Getting started in Vyper, it's actually quite hard. So on a Mac, you can get I think Python 3 is installed on default. In Ubuntu 16 and below, you have to install Python, and it should just be as simple as that. But I haven't ever got it to work. If we go back to the word experimental, that's probably right. So once, if you get it working, you should just be able to use the command internal Vyper, your contract, and use the extension .vy, and to try and get you along. They've got a Docker image, Vyper Online, which I'm going to demo, and they've actually got a VS Code extension, which I found today prepping for this. So with the VS Code extension, I still haven't got this to work either. I didn't really try too hard. It's not through the marketplace. You actually have to install it natively. So I'll just jump to that and show it. But it is pretty cool if you get it working based off them. So yeah, we get all the linting, etc., as you'd expect from VS Code. So it's probably worthwhile if you're going to play, get this guy going first, and then you get the autocomplete, etc. So you can find it on if you just Google GitHub Vyper. Oh, sorry, distributed code Vyper. You should be able to find that and let me know if you get it working. Okay, so back to this guy. And like I said, they got Docker, etc. Okay, so with Vyper, they don't have this idea of I guess the principle here is that they want to make it easy to write and not have misleading code. So some of the differences, as I explained, these are the reasons based on those principles, is what's different from this into Solidity. So with Vyper, we don't have modifiers. They claim that it can make the code a little bit misleading. So we all know modifiers. Yes. No? Okay. So I might just jump backwards and forwards. So what they're saying here is, if I get my remix terminal open.
You follow that logic?
Sorry?
You follow that logic, but it's misleading to have modifiers?
I kind of do. I like more attributes than modifiers. So this is Solidity. So we can go. Right. got our whatever. Yeah. Okay, so with solidity we give our function. And then we have our logic within here, and then what we do with the modifier, we have another bit of code down here, which is something like only owner, and then we can express our logic in here. So something like acquire, and then if we jam that guy up here, etc. So that's a modifier there, and then if we can try and get that guy across. So what the argument is with solidity, we decorate that guy here with this function here. So what we're saying is this function now uses this method modifier, which is down here. So we could argue this could be wrong or not implemented correctly, etc. So like Sam said, you can make your own call, but Vyper have chosen not to use modifiers.
But isn't it really that it's confusing, because essentially that bit of code is pasted into the front of that function, and not all people think that's exactly how it works. They sort of don't only own the ship if it's going to do what it says it's going to do.
Yeah, so I'll show you like some properties, like attributes in Vyper, which like I said, like Python based, and C# and Java, I like them a bit better.
The thing along there's another way down the book called condition-oriented programming, which kind of talks about the rationale modifiers. I think I aligned more with that because it's kind of about wrapping up side effects and things.
Yeah.
Preference, I guess.
Yeah, but yeah, takeaways, they don't have modifiers. No inheritance, and this is their argument that it requires people to jump between multiple files to understand what the program does, which may have some security concerns. So again, if you buy that argument, maybe use Vyper if you don't use Solidity. They don't use inline assembly. So Pete, I think you spoke about inline assembly on your advanced Solidity. So with Vyper we don't use inline assembly. So for those who don't know, you can actually get bytecode as well and put them into contracts. Pete, do you want to type how to do it? But it makes it, I guess, you're getting compiled code within object-oriented code, which is arguably pretty hard to understand the logic there. There's no functional overloading, which again can cause confusion. That's their argument that I actually like functional overloading. So again, we're just saying here something like the code foo with hello. With functional overloading, you could have a second one, hello world, which may have adverse effects. There's no operator overloading, so that's where we do that, like plus equals. They argue again that is against their security principles, so they don't actually use operator overloading. And we don't have infinite loops, so we protect against these gas attacks. We have no binary decimals as well. So we have fixed point decimal, which argues better, can be written better, and some examples there. So based on it comes back to Python based. Okay, so that's kind of the again, this is just taken off the README of Vyper. So I'll just do a bit of a demo on some of those principles. So I'll do a little bit in Solidity and then a little bit in Vyper. So as mentioned, you can use this online IDE called Vyper.online. I'll just make it bigger. Have you been doing much Vyper, Sam?
No.
Okay. I did a bit and then I dropped off for a couple months. So, okay. So we're going to do a simple contract here. It's kind of like a maybe like a term deposit. So we're going to use this idea like of only owner. So the contract has an owner. We're going to set a lock period. Then we're going to, well, the owner can set a lock period. Then we're going to lock the contract from a day with a delta. We're going to deposit funds into if it's not locked, and then we're going to be able to withdraw out when it's after that period. So the first thing, as noted, we don't actually use, we don't actually do like a contract title. We don't actually think about it that way. We actually have this file here is the actual contract. So again, we're trying to get rid of the paradigm of contract, of object-orientated, where I think object-orientated doesn't make sense in a lot of smart contract programming. Like an ICO doesn't feel like an object to me. It feels more of just a bunch of functions that are related. So first one here, we'll do our like traditional properties. So this is the variable name, and then we have our access modifier, and then the type. And we don't have any semicolons, which I'll probably type as we go. And then I'm going to do a locked from, which is public, and this is a new actual function in, or a property in Vyper called timestamp. So there's a few other ones we've got called timestamp, time delta, which start in Solidity, which makes things cool. And we're going to do lock delta. I don't know why that doesn't go blue. So anyway, they've introduced in Vyper a couple of different operators and commands. So some other ones is you can actually do splicing, concat, some other string operators like that you would be familiar with in JavaScript. And to find the opcodes, it's very poorly documented. You have to look at the I'll bring up a link there we go. So that guy there, so you have to actually look through some of the GitHub. Also, that's VS Code. But anyway, it's poorly documented. So if you go to the README, sometimes you can't find some of the new operators, which is a shame because they're pretty cool. So you actually have to go into some of the hidden documents. But anyway, we'll carry on. So that all makes sense. Now, the other thing with the next thing we notice that the difference is with Vyper is the constructor. So we actually use, for those who are familiar with Python, the init syntax. Okay, so again, people are familiar with Python would have seen that before. That's just initialization of the file. And the other thing we notice, yeah, anyway, we're back. The other thing we notice is we don't have braces and again with Python we just have indentation. So Solidity and JavaScript would do something like that, but we don't actually have that in Python or Vyper, so we just do this indentation. So okay, so that is the same as what we've done up in here there we go.
Don't have to remove the brackets off only.
What's that?
Do you have to remove the brackets off the modifier only? So it doesn't execute right now. They're optional. Is that
They're optional because if you have a value in here, yeah, so you can pass them in that way. Yeah. So that's one of the first differences. So now if we've done everything right, we should be able to compile. We have done something wrong. Good good call. Now the other thing for access modifiers on Python, on Vyper, we use the attributes such as JavaScript, as Java and Python, and I like that better. So instead of having decorated at the end here, we put them up in that guy. So that should compile. Maybe not. Oops. Okay, let's try it this time. Okay. So if those two contracts were the same, then the bytecode should actually arguably read pretty similar, depending on the compiler. And they should behave the same way. Okay, so the next part I want to look at is then giving a function. So I'm going to do define my function, the def, do a set lock, which I'm going to lock this contract, or set the lock times, and just pass in the parameters from. Again, we can use our new type timestamp and our period, which is of type time delta. Okay. And then we can do our defending with the assert. And we can do something like, so that's the same as, because we don't have a modifier, we have to put that there, inline. And then we can use our block time, so from, just to do a bit of defending, and okay, so that's just so someone can't lock a contract from a date that's been in the past. And then...
Can the assertions send out an error message like Slurpee ones?
Good question. Good question. Google.
Okay.
I don't know. Not sure. But they don't do that operator overloading, so maybe not, or maybe it's just defaults to null or something. So there is, like I said, I'll find that page where it shows all the default values, all the new types, etc. as well. Like, it's kind of hidden within the GitHub repo, which is a bit of a shame. And then what I'm going to do here is just set the properties, which are these guys up here, the public properties. And again, we can just do our values. I think that should compile. Nope. What went I wrong?
You haven't defined what period yet.
Oh, it shows block delta. Sorry, that's what I should have done. We'll carry on. Sorry. Put that guy on. So, carry on. I'll come back. Alright, anyway, we get that, I'll work out in a second. And then, okay, so that's just how to set the lock period. And then another, I don't know if I haven't done this, done the public. Actually, that compiles. Yeah, okay. Alright, so the next part I'm going to do is look at a constant, or in Solidity we call it a view now, so where the contract is like a read-only property, which doesn't take gas, so again we'll call it public, set the access modifier to public, and then we'll do use the attribute method again, or attribute style I should say. Do our def is lock, and this guy returns a boolean. Okay, so that's the syntax there for a return type. I don't know if there's multiple return types, I'd have to look. Probably. And then we can just do return some kind of logic, time, and greater than self lock from, and then we don't use stuff like that. We use and. And we can just do for time. Okay, so there's a couple of things here, what we're doing, so that are different from Solidity. We use the words and, like I said, instead of using that, you know, we can use operators such as not or is. So for this logic here, so we want to say, is this contract locked? Well, we're going to say, is the block time greater than lock from? And the timestamp is less than, and this we're doing some date time operators. So we're going lock from plus the delta of the lock period. Lock delta. No, I keep putting lock period. Okay. So yeah, a few little things different Solidity, and like I said, then there's this syntax here. When we set
call set lock to set the time delta of existence when external world talks to this.
from the thing, yeah, the calling function.
I mean, I would imagine
It's probably an epoch, yeah, or something.
because those all the daytime stuff is just going to be concept.
Yeah. Well, we could compile and throw it into my wallet and see what we can put in. So, actually compiling, so we're getting there. Now some other properties of smart contracts. We want to make this guy payable, so simply make this guy public and simply make him okay, and then we can do whatever logic we like in here. I don't know why. I don't know why we want that, because we want anyone to send funds, but again, it's kind of an important point, because we don't have modifiers. If we want to do it, we have to do it in line each time. So up to you if you like it or not.
I guess it leads to a copy and paste coding, which could lead to errors.
Yeah. I'm not here to argue whether it's right or wrong, just show the difference. So yeah.
It's totally the same as is, or it is like an instance check.
Yeah. I'll bring that up the bitwise operators. But yeah, good call. We should check. We might actually have that. Whether it's there should be the same instance, right?
Depends on the member block, doesn't it?
Yeah, but it should be written. So, good question. Yeah, so again, just showing another one. So they're not there, and then what we're going to, just another difference here to show the differences is what I don't want to do here is throw an event. So in Solidity, if we do this guy here, we would do event, and then down here we use Okay, so for those who are not familiar with events, so what we do here, because if we've got an application watching the blockchain for state changes, what we can do is we can raise an event which your application can subscribe to and then perform an action. So in this case here I'm saying, well, if the withdraw function gets executed, then my underlying application will get notified, and away we go. And we could have, we could pass through things here like and then get the value back out.
Is that a new review?
Since about 2 or 3 versions ago. Yeah, I think it came out in 22.
That's good, because there used to be distinct functions.
Yeah,
That's what broke it down, right?
yeah. So yeah, that's a new guy. So in Vyper, I'll jam it up here. The same one is we declare our event. I don't call it deposit because we'll fire the event under deposit. And we use that syntax, and then we pass through these guys here. And then something like, and again, this is a new type. That's a new type in, as opposed to Finny and all those guys. In Solidity we can use like this we_value, and again I'll try to find that list so you can see all the other guys. So then to raise that event we use the log keyword with the property, the method name, and then pass through whatever guys we like. And then same as like Solidity in that respect. Okay. That's that. What's that?
Is that compliant?
Yeah. Why wouldn't it?
I'm going to have Python experience here, but
What have I missed?
well, I wonder if we can use curly braces around that deposit call to assign those properties, because up the top on line 13 it looks like the Python dictionary to me.
Yeah,
But is that a type thing?
like you're saying there, to pass through the.
And you put it to label too, I guess.
Maybe I don't need those guys up in there. I'm sure this did compile. Alright.
Maybe no curly braces up top.
It says there's some problem up in line 13, so yeah.
I don't know.
Home that's fixed it, but the arrow's down at the bottom now.
Oh yeah, that guy, yeah. Debugging live.
Can you dev it?
Well, here's one we can refer to. So that was pretty much what I wanted to cover. So when you do open Vyper, this is the default guide they put in the traditional voter contract. So this is kind of so you can base on, but they do use the squigglies.
So it's all mapping.
Yeah. Again, not expert. Well, let's just not raise the event. Alright. So that should compile hopefully. I know. So then we should be able to get the bytecode, deploy it, my wallet, and away we go. and then if hopefully we've written everything, then it should work, and can write a contract in Vyper. Oh, that's pretty much all I had at the moment on Vyper.
Sure.
A little bit
very experimental.
bit shorter, but yeah, I kind of like it a little bit better than Solidity, but yeah, it's still, I'm not an expert, it's still experimental. Silly.
So,
Yeah.
does it support interfaces? I know it doesn't. You said it didn't support like IO and inheritance, but does it at least support interfaces?
No, not that I know, because it doesn't. Yeah, not that I know.
Well, interfaces is useful because then when you come out with a new version of the contract, you haven't written your code to the actual implementation, you've written it to an interface. So as long as you obey the interface, it should all be good.
Yeah. So yeah, like you can see here in the documentation, it's very it's still experimental. We use the word. So you can see here the operators like not and. There you go. So it is equality. And then there's the new operators. Like I said, there's timestamp, etc. Time delta. You can use these bitwise terms and some other new ones, like I said, like the string concat, etc. So
are they saying that if it's in capitals, it's bitwise, and if it's lowercase, then it's Boolean?
what are you saying up here?
So that seems to be capital. Hold it.
That's just the.
Oh yeah, that's it.
So to use that, that's the operator there.
Yeah.
So, but you know, they argue that it's easier to read because you're expressing it as that, as opposed to some other symbols. So I will just throw in that Abby sample. We'll see what it comes out as. Down tab, sorry. I've lost that code, so I can't, but you could see what from the Abby, I guess, Sam, and see what kind of passing it, but I'd be surprised if it wasn't and it's because the Abby pretty much should be the same, so, yeah. Yeah.
Well, thank you, Lucas. Does anyone have any questions?
Yeah.
More commentary, I guess.
Yeah.
I mean, it looks much more pleasant and safe to use than Solidity to me. You know, the modifier part, I would kind of disagree on, but everything else that you mentioned from their docs are serious problems with Solidity.
Yeah.
I don't know if you know if it's still an issue, but particularly the inheritance model. So if you've got two base classes and implement properties on methods with the same name, the compiler will just like blindly override one with the other, and so most complicated systems that I've worked with, if you've got like an ownable base class, you don't have to run your unit test for that ownable behavior on every single class that subclasses it rather than just the base class, just to make sure you inherit it properly.
Yeah.
That the compiler wants you these days. I guess where I'd see the limit is in the absence of inheritance, you're doing it all with composition, which is great. I think it's a better paradigm anyway.
Yeah.
But I could see that being a bit heavier gas-wise because you're going to have to deploy every contract individually rather than being able to inherit them all into one deployment. But yeah, otherwise it's awesome.
Yeah, it's fair. Like I say, I think it's good to have more choice. I'm wondering, you know, what this will do different because than Serpent. Serpent was the first and died.
I think Serpent, was just kind of an early iteration to this, right? At this they've probably slowed it down slightly by putting some of the safety stuff in it that Solidity doesn't have, like checking the radars before iteration and stuff.
Yeah.
But yeah, I kind of read it as this is what Serpent was meant to be.
Yeah. I mean, they have the thing, same with Python lists, mappings, again, but I'm not, I've only been mucking around with it, so I'm not, by any means an expert, but yeah, definitely have a look and, I guess watch this space for it. So, but yeah, I'm pretty excited to have another language as opposed to Solidity.
The external libraries and calling out contracts or things like that.
Yeah, good. I haven't looked at it yet, but yeah, I'm not sure how to do it, but you'd assume it would be able to. So, but whatever the syntax is, yeah. So.
I mean, it's just a different way to get to the same bytecode.
I guess the other cool thing about having no unbounded loops is that you'd be able to prove termination on a Vyper contract, although you wouldn't be able to prove it properly because it compiles down to you can't prove termination on anything else.
Yeah.
So I don't know if that's pragmatically useful, but I guess it can be helpful.
Yeah. Yeah, cool. All right.
Well, thank you very much, Lucas. Next week, Brett is going to come and tell us all about Ethereum 2.0. I know I'm looking forward to it for one. So, it's going to be fantastic. And thank you very much, Lucas, for filling us in on Vyper. Right, thank you, everyone, and see you next fortnight.